Ferrari promised us a silent winter. They told the world explicitly that everything would be hermetically sealed.
Right.
No leaks, no whispers from Maranello until Project 678 rolled onto the tarmac.
But what we're hearing right now is not silence.
It's an explosion. It's an explosion of contradictory intelligence. Every rumor, every highly placed leak suggests one of two things.
Yeah.
Either Ferrari is taking the biggest, most reckless engineering gamble of the decade, or they've just unleashed a 2026 masterpiece.
There is absolutely no middle ground. And that's what makes this so captivating. We're looking at reports from sources, incredibly well connected inside Maranello.
Okay, so let's unpack this. Project 678 is now in fabrication. They're printing the components.
But the car we're about to see is not the final race car.
Not even close. And that's where this all starts.
That compressed timeline immediately spikes the risk factor. But before we really get into the technicals of it all, let's just quickly say,
yes,
this segment is part of our news coverage of recent F1 events.
Thank you. So that deadline, the first car, let's call it 678A, was approved and sent for fabrication just 2.5 weeks before Barcelona.
2.5 weeks. I mean, to put that in perspective for you, the margin for error for the engineers, for the fabricators, is practically zero.
And that's where you start thinking about historical failures.
Oh, absolutely. When you push a schedule this hard, you are just inviting catastrophic failure. I mean, look back at Williams in 2019.
Lotus in 2015.
Exactly. Cars being late, missing the first day of testing.
Yeah.
You lose that time with brand new regulations. You're losing performance before the season even starts.
So why do it? If the risk of a total meltdown is so high, why approve it so close to the wire?
Because the car we see in Barcelona, 678A, it isn't built for speed.
Right.
The reports are clear on this. It is purely a systems evaluation mule. The goal for those first 3 days is, well, it's shockingly fundamental.
So they're not chasing lap times?
Not at all. They're chasing data integrity.
Okay, so what does that mean in practice? What are the actual objectives on track?
The list is simple, but it's absolutely vital. 1, reliability. Does the engine and the chassis actually hold together under load?
Yes. Does it work?
Does it work? 2, movable aero. Do the new active systems, the wings, the flaps, do they function correctly without failing? 3, ECU parameters. Checking all the new consumption controls. But the big one, the silent killer, is correlation.
Explain correlation.
Yeah.
For everyone listening, prepping their F1 office pool, why is this one word so critical?
Correlation is everything. It's matching the data the car makes on the real track downforce, airflow, with the data from the factory's wind tunnel and CFD simulations.
Okay.
For 2026, the rules are so radical that if that track data doesn't match the factory data, their entire winter of development is basically useless.
So they've been designing a car based on digital assumptions.
Precisely. And 678A is the proof of concept. It just needs to move, and more importantly, it needs to produce trustworthy numbers.
So 678A isn't a race car. It's a very, very expensive, high-speed measuring device.
That's a perfect way to put it. It's camouflage. And that leads directly to their late reveal strategy.
Right.
Reports suggest 678A is just the baseline. The final aerodynamic configuration, the real war machine, 678B, it won't appear until the last day of the second Bahrain test.
The last day. That's, what, a week and a half before the first race in Australia?
Rarely.
But what if it's flawed? What if that 678B package just doesn't work as they expect? They'll have zero time to correct a major issue. Isn't that a huge risk?
It is an astronomical risk, but it also suggests they think they have a deeply guarded innovation. It's a strategy to keep rivals guessing.
We have seen this play before, though.
We have. Think about 2022. Mercedes shows up in Barcelona with a, pretty normal-looking car.
And then they get to Bahrain.
And they shock the entire paddock with the zero-side pod concept. The late reveal is the ultimate poker face. They're willing to risk it all if they believe the idea is truly revolutionary.
And that level of secrecy, it's not just Ferrari, is it? The whole paddock is on lockdown.
It's tighter than any time I can remember. We're used to the teasers, right? Every winter, a team accidentally leaks a glimpse of a winglet.
Yeah, a cryptic silhouette or something.
In this year, nothing. Not a single team has shown any meaningful bodywork.
So why is it so much more intense this time around?
Because the game has changed. It's all because of the new mobile aerodynamic rules. Small details that used to be incremental gains are now massive performance differentiators.
How so?
Well, think of it like this. The stationary wing is important, but how the air behaves when the moving parts open and close, That's the real secret sauce.
Oh, okay.
The shape of a front wing end plate, whether a flap is square or round. These tiny details now define the entire performance window. If you show your hand early, your rivals get 6 weeks to copy it.
And speaking of specific aero intel, we got some details on the front wing mechanism.
Yes. This is where we could see the first big split in design philosophy. We know the front wing will have a DRS-like opening mechanism. The common assumption is that most teams will go for a single centralized actuator to move that flap. It's simpler, it saves weight.
But Ferrari might be looking at something a bit more complex.
That's the fascinating part. Some teams might use 2 actuators on the front wing.
But wait, wouldn't that just add weight and complexity? Why would you do that?
That is the question, isn't it? Why add weight if it's the enemy? The answer is micro-deflection control.
Go on.
At 200 miles an hour, a single actuator allows for tiny bits of wing deflection at the outer edges. 2 actuators placed near the load points stiffen the whole thing up dramatically.
So it's about stiffness.
It's about controlling that deflection. It lets them run a much more aggressive main plane structure, giving them greater control over the airflow, especially in that transition from high downforce to low drag.
So they're trading a tiny bit of mechanical weight for a potentially huge aerodynamic payoff.
Exactly. And that single versus double actuator approach could be one of the key design battles we see early in the season.
Okay, let's pivot from aero to the heart of the machine. Because if the aero strategy is high risk, the engine choice is, well, it's downright revolutionary.
It's the ultimate technical gamble in an era that's supposed to be constrained.
We know the 2026 rules push compression ratios way up. The rumored limit is 11.6, but we're hearing Mercedes and Red Bull powertrains are pushing for 11.8.
And every tenth of a point there is free horsepower.
Here's where it gets really interesting. Ferrari has committed to a radical choice for the most stressed part of the engine, the cylinder head,
They've opted for an alloy steel cylinder head.
instead of the traditional aluminum alloy.
Correct.
Now, to a lot of listeners, that might sound like a minor detail, but this is a massive engineering decision. Explain why aluminum is the standard.
Okay, so aluminum is standard for 2 huge reasons.
Yeah.
Weight and cooling. F1 is a fight for every single gram, and aluminum is light.
Right.
And second, it has fantastic heat dissipation. It sheds heat really well, which means you can run smaller cooling openings on the bodywork, which means less drag. Aluminum is the efficient choice.
And yet, Ferrari has just thrown that whole playbook out the window. They've picked steel, heavier, hotter steel. Why?
One reason: brute, unrelenting physical resilience.
Okay.
Steel has a significantly higher resistance to the extreme pressure and temperature you get with those ultra-high compression ratios.
So it's about reliability under huge stress.
It's about reliably running the engine at potentially rule-bending compression figures to find that extra power. Steel just won't distort or fail under forces that might push an aluminum head past its absolute limit.
They're sacrificing weight and cooling for raw, reliable power generation.
It is a fundamental trade-off that defines the entire car.
So let's talk about that trade-off. If it's heavier and hotter, they must have to run more open cooling, right? Which means more drag.
That's the trillion-dollar question for 2026, isn't it?
Is the theoretical horsepower gain really worth the tangible aero sacrifice?
Look, if the steel head lets them reliably unlock, say, an extra 20 horsepower that Mercedes or Red Bull can't match because of the limits of aluminum, that's a gain you chase all day long.
But the drag could cancel it out.
It absolutely could. If they're forced to run massive cooling dents, that could easily negate the whole game on the straights.
Which brings up another question. If steel is so much better for this, why aren't we hearing that Honda or Audi or anyone else is doing it? Is there a fatal flaw here?
The fatal flaws are usually manufacturing complexity and fatigue. Working with these kinds of alloy steels is incredibly difficult, and they have to be sure it won't develop catastrophic fractures after just a few hundred miles.
So most would just stick with what they know.
Exactly. Aluminum is a known quantity, but Ferrari is trying to get clever with it. Reports say they've partnered with firms like VLS Austria to design ultra-thin, lightweight structures for the head.
So they're trying to get the best of both worlds, the strength of steel with the weight of aluminum.
They're trying to mimic the low density of aluminum through just incredibly advanced engineering. It's a huge effort, but it's also a massive unknown.
And we have no idea if anyone else has made a similar move.
None at all. We have zero intelligence on that. For all we know, Ferrari is completely alone on this island. They could be pioneers, or they could be the first ones whose engine fails spectacularly.
So let's just synthesize all this for everyone listening. You have extreme aero secrecy, with the real car being revealed just days before the first race.
Right.
And that car is powered by an engine that trades known penalties in weight and cooling for a theoretical gain in power and resilience.
And the reports coming out are just wildly conflicting. One day it's a total failure on the dyno, the next it's an alloy marvel. The only thing that's certain is the uncertainty.
Which raises an important question then. In this era of regulatory parity, of tiny margins, does taking a high-risk path like this represent necessary genius, or is it just unnecessary folly?
It is a pure performance versus reliability trade-off at the absolute ragged edge of the regulations. You have to decide if Ferrari has found a championship-winning loophole or if they've just engineered their own Achilles heel.
And we won't have the answer until the lights go out?
Not a chance.
Don't miss a single lap of this season's development, the analysis, or the drama. Make sure you are subscribed to DRS Zone on TikTok, Instagram, and YouTube for all the fastest analysis.